Okay, picking up where we left off with synthetic division. I was just about to get it set up when my recording time ran out. So here we go, finish up the notes here with the second video. So with synthetic, we're going to set up kind of an outline. Basically, here's how it works. You're going to list out your coefficients from every term. So that's a 1, 1, -7, and 5. In the little kind of half box up here, what I'm going to put is what's called the 0 of the divisor. And the 0 of the divisor would be 2. In other words, what's the value that would make that expression 0? Synthetic is definitely a different approach. It really works nothing like, well, I shouldn't say nothing like long division, but it doesn't look like or feel like you're doing it, but it has some similarities. But definitely a different way of doing the problem. Remembering some of the steps, or if you guys are kind of learning this for the first time or relearning it, the first number just gets brought down. So you drop that down. Then we're going to go through a series of multiplications and additions. And it starts out by multiplying. So you do 2 times 1. So 2 times 1, which is 2, and then it's addition. So here's a main difference between long division and synthetic. It's this addition, whereas long division is subtraction. So you add. And then you just repeat this process to get to the end. So now I'm going to take 2 times 3, which is 6. Then I add down in the column, which is -1. 2 times -1, which is -2. Then I add down that column, and I get 3. Now, sitting there in front of you actually are the lead coefficients for the quotient. So if you think about it, you took a cubic and you divided it by a linear, or you took a third power divided by a first power. It should make sense that your quotient would start with the second power. And right in here sits the quotient. Of course, here's our remainder, right? So if I was doing mixed number style, it'd be plus remainder over my original divisor. So those numbers are just going to be your lead coefficients for your terms. Should start with 1, well, if you think about it as dividing like basis subtracting exponents, x to the third divided by x, should start with x squared. Synthetic is really simple once you get the hang of it. It's also a lot quicker than long division, but again, it's also restricted to just a certain kind of divisor. Okay, we're going to run through some more synthetic problems, but we're also going to do them as with a purpose, like what else does synthetic do for us? But there's the process, so you get to see it a couple more times. One of the things you can do with synthetic is actually use it as a way to evaluate. So there's 2 kinds of evaluate. There's direct substitution, there's what's called synthetic substitution. We're using the word synthetic division, but it's the same concept. For example, if you took that long function in the example there and I said, what is the p of -2? Direct substitution would tell you you'd have to just plug in -2. Plug it in and go. Just calculate. With that particular problem, that might get to be a little bit heavy duty with the calculation. With synthetic, it probably would actually be a little bit easier. What the remainder theorem says is the remainder is the solution. So the remainder is the p of -2, which is kind of a nice method of nice purpose of synthetic. So you can use it as a way to evaluate. It also will help you when you're trying to find additional points for graphing. We'll kind of hit that idea when we get to the next section. But we're just going to set up a synthetic and run through the synthetic. So in this case, I'm using -2. List out your coefficients. One thing to be careful with synthetic, just like long division, is it's actually, if you're missing an exponent, which here we're not, it goes 4, 3, 2, 1 constant. But if you're missing one, you'd also want a 0 placeholder. If you don't put a 0 placeholder in, that'll actually mess up your coefficients on the quotient. Anyway, going through the work, one more time, right? Bring your first number down. Then again, go through a series of multiplications and additions. So the first one's a multiplication. Then we're adding down in columns. So we've got 20. You just kind of keep working your way through it. I guess I got to kind of finish it up. Let you guys catch up a little bit. So what we figured out by synthetic is that's the answer. Now, doing that with direct substitution, I think, would actually be probably more complicated as far as the calculation, and you might even go to your calculator to do that. This one, the numbers got a little bit bigger, but it wasn't terrible. Okay, so there's the basic idea. For synthetic, one of its purposes is a means of evaluating. The other purposes we're going to talk about next are actually a way to figure out if what you have is a factor. So the factor theorem is a test. And basically, it's kind of like saying, does your factor go in evenly to your function, just like when you're doing with numbers. And if you're doing with numbers and you say like 5 goes into 30 evenly, what you're really saying is there's no remainder. And for us, what no remainder means is you got a remainder at 0 using synthetic division. So now synthetic becomes a test. Is this thing a factor or not? And it's, again, it's going to be quick and easy to do. You're going to set up, put your 0 in, lay out your coefficients. Now in this case, you notice there's no x squared term, so you'd want a placeholder for that. And what we're looking for is question mark. Am I getting a 0 remainder or not? What's good about synthetic, again, is it's nice and easy. Okay, that right there is a check. So what I know is, yes, it's a factor. Now the question about what the other zeros are is based on the quotient. It turns out now synthetic becomes one of our factoring methods. So you can go back to chapter 1 and say we looked at a lot of factoring methods. We didn't look at synthetic. But it is used to help you do factoring. Where actually the original problem maybe isn't factorable by looking at it and getting going with your traditional kind of factoring, but you're given a 0 to start the problem. Think about what's left. You've got the quotient, x squared plus x minus 6. That can be factored. If I said, what are the other factors? Well, they're x plus 3, x minus 2. What does it look like completely factored? Well, you'd have to build in your original 0. Now remember, from day 1, a 0 can be written as a factor simply by going x minus the 0. That's always the case. And then your other factors. So synthetic as a way to test if you have a factor, which is also testing if it's a 0, and then what's left being factored. So it actually can get you started in the factoring process. Now the catch here is you have to be given one of the zeros to get going, but it definitely will take us the rest of the way. So one of the other uses of synthetic, testing for factors, and also continuing with the factoring. The last little bit of this before we wrap it up is just kind of work the problem in reverse a little bit. So this is based on the connection from zeros to factors, not so much on a synthetic or a long division idea. But given a list of zeros, could you create a factor with a specific degree and then turn those factors into, a function with a specific degree, but then turn those factors into a function? And it's a pretty simple idea too. If you work this in reverse, you think about what your factors would be. 0 would come from x. -2 would come from x plus 2, and 3 would come from x minus 3. Now that's a list of factors from my list of zeros. But don't forget to finish it off in what was the original function. So what we're going to have to do is a little bit more work with this and distribute that x in. So there's a function degree 3 with those specific 3 zeros. Again, not a real complex problem, just like understand the connection between zeros and factors and the function. And that's pretty much it. Okay, well that concludes our notes for 3.2, division, whether you're using synthetic or long division. Again, synthetic has multiple uses, and we'll use those kind of right away in the next section or two, and then long division will come back into play for sure as we finish up the chapter.